course. Okay, so now we're doing a second student. This is fifth period on the 28th of September 2016. Okay, again, we want to do page breaks. These two pages especially I want separated. So I want a page break here. I'm not going to take points off for this today, but we will take it off for grading tomorrow. And so rubric is here, and I'll give him the 2 points for that. And next I should be seeing the purpose. Okay, got purpose, materials. I like this. You see how he formatted this? This is very, very easy to tell purpose from materials, from chemical reactions, and then I see the procedures. I would like to recommend to you that you start your procedures on a new page break. I'm not taking off for that now, but I'm looking at 30 procedures. Due to time constraints, I'm not going to read those, but it looks like you've got a pretty good set of procedures here. I warn you, since David's grading them all, and he has a relatively quiet room to be in, if he happens to notice that the same wording was used in two different papers, he's going to be looking. If there's plagiarism, both students will get a 0. If you're plagiarizing from another student. Okay, I'm looking at 31. The last one was 31. I don't have the paper to compare, but they need to be your procedures and not copied from someone else. Okay, we got a problem with the data again. Were you guys in the same data group, lab group? Okay, that's how that happened. Be careful, make your own. Okay, and here we got a -1, same problem. So you knew this was coming after seeing the last one graded. And okay, so we're in observations. I'm going to, for right now, go ahead and mark these in because I've already looked at them. The procedure was looking good so far as I could tell, as long as it's not plagiarized. And diluted phenol red. Okay, we got both measurements here, which is good. We got the volume, but we're -1 here because this should be 8.7 something. Because that graduated cylinder is capable of that much accuracy. So you have to have 2 decimals for any measurement made with a graduated cylinder. All right, and now down here the mass at 34.2 grams. The grams measurement is too short. And mass of the bag with all chemicals? I don't think so. Not mils. You want grams. And if it's grams, it's too short. Even if it was mils, it would be too short. Okay, this is grams. Okay, so we took some big losses here, just like your lab partner. 1, 2, 3, 4, 5, 6, 7, 8, 9. You end up with 1 on those observations. Now you got other observations here. When chemical reactions begin, chemicals turn yellow. Chemical reaction resulted in fizzing. One side of the bag was warm, the other side of the bag was cold. I would like you to say what was in the side that was warm, what was in the side that was cold. And then after the chemical reaction, it lost 1.4 grams, I assume. Okay, we're talking mass. And after opening the bag, it gave off a displeasing aroma. I would say that's a very correct description. Very displeasing. Okay, conclusion. Few of the observations made by me during the lab can be explained in various ways. Chemical reaction produced a yellow color due to the phenol red. Okay, phenol red is an indicator that turns yellow in an acid and pink in a base. Okay. So the fizzing noise was the indication that a chemical reaction was a success, and it actually was a chemical reaction. Okay. The bag also began expanding, which was another indication the chemical reaction was a success. Now, you left out everything about the um, conservation of mass. If it changed, if your bag changed mass, you have to have an explanation. Damien, are you listening at all? Well, wow, you're sure having a good time with other people while you're listening. You're a good multiprocessor. I hope that isn't reflected in your lab write-up. Okay, conservation of mass. Why did bag change mass? Almost all of you had a change of mass. Anybody did not have a change of mass? Okay, what are the possible reasons, folks? Why would it change mass? Yeah, you found? You're saying that the law of conservation of mass says that if a chemical reaction produces a gas, that there will be less mass. Did you get that? Yeah, okay. I just wanted to restate your statement in a way that helps you see what the conservation of mass is all about. It's hard to get a feel for that until you actually see it in action or you get the kind of correction I just gave you. Okay? So I'm hoping that that helped. Yeah? Because this is conservation of mass. It's first law of chemistry. That's what the name on the lab is. So we need to have something about that. So the statements that were made were okay, and I'm only going to take off 5, but I have to take off at least 5 because we missed the whole point of the lab. Okay? And then the handwritten procedure is at the end. So that gives you 10 points. And so we have 3, 13, 14, 19, 29. Okay, this is just about where most people are ending up, right around 30. So if were not watching, I will put this video up online and you can watch it again and make sure that you haven't made the mistakes that Sarkis and Minas made. Okay? So that's it. Leave it.